Okay, this is the translation notes and practice. So it says on the top of the notes on the left side, it says transformations. A translation is a type of transformation. So transformations is like the big category, and then there's subcategories. So translations, reflections, rotations, dilations, all those would be types of transformations. Okay? So translation. Okay, is an operation that moves a figure. Okay, the new figure is the image, and the original figure is the pre-image. Okay, so a translation is a type of transformation. Okay, we're going to take an image, some sort of geometric figure. It could be a circle, a line, a triangle, quadrilateral, any sort of geometric figure. And we're going to translate it from the pre-image. We're going to be given a pre-image. We're going to translate it, and the translated figure is called the image. Pre means before, so we're taking a figure before, we're translating it into the image. Okay. The translation means we are moving the figure, so it's not changing size or shape. It's just simply being shifted horizontally or vertically, or a combination of both. Okay, so we have a triangle. Okay, and we shift it to the left. All we're doing is moving it over. This would be our pre-image. This is our image. Okay. Translating it. We're shifting it over. We're just moving it. It's not changing size or shape. It's just moving over. Next paragraph. We're going to put a mapping. Okay, a mapping is a correspondence between sets of points, so that each point in the first set corresponds to exactly one point in the second set. In algebra, a mapping is called a function. So as an example, if we have f of x equals x plus 3, okay, your input into this function is x, your output is x plus 3. So we're mapping each input, each x value is getting mapped to x plus 3. So 4 is getting mapped to 4 plus 3 is 7. 5 is getting mapped to 5 plus 8 is 8, or 5 plus 3 is 8. And 6 is getting mapped to 6 plus 3, which is 9, right, and so on. So each set here, each number here is getting mapped to exactly one number in the second set. So basically, by mapping, we really mean we're putting in an input and we're getting an output. Okay. So each point in the first set, so all the numbers we could put in for x, are going to correspond to exactly one point of the second set. And in that case, it's going to be a number that's 3 bigger, 3 units larger than it is. Next paragraph, on isometry or isometric figures. Okay. Okay, this is when the image and the pre-image are going to be congruent. So it's going to be a rigid transformation. That's translations, reflections, rotations, because all of those are rigid transformations because they don't change the size or shape of the figure. So all of those transformations are isometric because they're not changing the size or shape. Okay, so it's going to map every figure onto a congruent figure so that the image and the pre-image, the image, that's what we translate it into. Okay, and the pre-image, which is our original, pre meaning before, are congruent. So when our image and our pre-image are congruent. So if we have a triangle and we shift it over to the left, it's going to be isometric because it's still the same size and shape. All we've done is translated it over. We've just shifted it over, changed nothing else. We haven't changed the size or shape. Okay, so since they're congruent, we're going to preserve the length of the figures, any angle measures we have, any parallel lines that we have, and our betweenness of points. So basically saying everything is preserved except it's moved its location in space. It's now located in a different position in space or in the coordinate plane. And that's the only thing that's changed. It's just moved up, down, left, or right. Okay, so that's the first side, half of the first page. Okay, so we can fill in a couple blanks on the second side. So this is going to be translation. So we're moving every point of a figure the same distance in the same direction. So this is translation. Okay. A line has an infinite amount of points. Lines are what make up triangles and other polygons. So polygons, triangles, quadrilaterals, pentagons, they're all going to have an infinite amount of points. Our triangle, for example, has 3 vertices, but each side of the triangle has an infinite amount of points. So our triangle has an infinite amount of points. So when we shift it over, every single point is going to move the same distance in the same direction. So if we just shift it over to the left or to the right, it's just going over the same amount. Each point is going to move the same distance. A translation is isometric, again, because we're not changing the size, or is an isometry because we're not changing the size or shape. Translations in the coordinate plane can be described by the mapping notation. So here's where we are getting into the notations. We have x, y. Okay, so in all of our problems, we're going to be dealing with the xy plane, the coordinate system. Okay, so every point on here is going to have an x and a y value. Okay, so maybe this is x, y. This point here. Okay, but we want to translate it, so we're going to want to map it. X is going to get mapped to something like x plus a, y to y plus b. A is going to then represent the horizontal shift. Okay, the number of units we're shifting horizontally, and b is going to represent the number of units we're shifting vertically. So if we're shifting to the right, A is going to be positive. If we're shifting to the left, A is going to be negative. If we're shifting up, B is going to be positive. If we're shifting down, B is going to be negative. And we want to note that this is not like the equations for circles or parabolas or anything like that where you have to switch signs. If it's positive, you're going to the right. If it's positive, you're going up. Negative left, negative down. Okay. So if we were shifting this to maybe up here, this would be x plus 1, y plus 1, or something similar to that. Okay. And then we have the preimage of a translation is the original figure. So we have the preimage, we translate it or shift it, and then that's going to become our image. So, but the preimage is the original. The new one is the image. Preimage before. Pre means before. So preimage comes first. Then you translate it and you get the image. So now to examples. We'll do some examples. I'm going to graph the image. Under the translation, xy maps to x plus 3, y plus 6. And then we want to write the coordinates of the new points. Okay. So let's write our equation here. We have x, y. X is going to map to x plus 3. And y is going to map to y minus 6. So we have our pre-image already drawn, okay, with our 4 vertices for our quadrilateral. Again, there's an infinite amount of points in this quadrilateral, but we're just going to look at the 4 vertices. Okay, the first one is negative 4, 1, which is this point right here. Okay, and we want to translate that point according to our mapping notation up here. There's two ways to do it. The first way is we can use our mapping notation directly. So we have the point -4, 1. So the x value is -4, so this is -4 plus 3. The y value is 1, so this is 1 minus 6. -4 plus 3 is -1. 1 minus 6 is -5. Okay, so a prime would be -1, -5. The other way we can do it is by counting. So -1, -5 would be right here. Okay, the other way we can do it is by simply looking at how much we're shifting the pre-image horizontally and vertically. So horizontally, we're going to go 4 to the right. 3 to the right. So we're starting at point A here. 3 to the right. That's 1, 2, 3. And then we're going 6 down. It's negative. 1, 2, 3, 4, 5, 6. And that point should be 1, -5, which is what we got by substituting in to our notation. Second point. Close the windows. Okay, second point is -2, 4. Okay, which is up here, -2, 4. Okay, if we want to substitute that into our notation up here, okay, that's going to be -2, 4. So we're going to plug in -2 for x, so -2 plus 3, 4 minus 6. -2 plus 3 is 1. 4 minus 6 is -2. Okay, we could also do just by counting. So we're going right 3, down 6. Right 3, 1, 2, 3, down 6. 1, 2, 3, 4, 5, 6. And that is 1, -2. Okay, next point here is point C, which is 1, 2. So again, we can just count 1, 2, 3, down 6. 1, 2, 3, 4, 5, 6. It should be here, which should be 4, -4. Okay, let's just substitute in just to see what it should be. So 1, 2, 1 plus 3, 2 minus 6 gives us 4, -4, which is what we got. And then our last point here is point D. Again, we can go over 3, down 6. Okay, if we want to put that in, it's going to be -2, -3, -2 plus 3, -3 minus 6, which is going to give us 1, -9. Which is what we got. So we can now draw in the rest. And there's our image. So this was our pre-image. Okay, the original figure. We then translated it according to the mapping notation. We shifted all the points, every single one. We did it by shifting the 4 vertices and drawing in the rest. But if you took any point on here, any of the infinite amount of points in the quadrilateral, shifted them 3 over, down 6, they're going to lie on our new image. So the last one here was 1, -9. Okay. So that's the front side. If we go to the back side, okay, we'll do these 2 examples here. So it gives us our mapping notation down here. Okay. And we can find our 3 points by looking at the graph. So here's 0, 0. So this is 1 point, 1 vertices of our triangle. So again, there's an infinite amount of points on the triangle. We just want to look at the vertices though. Okay, so this point is 0, 3. Okay, so we then have negative 4, 4. Okay, so we have negative 4, 4. And our last point here is negative 1, 1, 2, 3, negative 4. Okay. So there's our original figure. There's our 3 vertices, and we now want to translate everything 1 point to the left. We want to shift everything 1 to the left and up 3. So let's start with the red point, the 0, 3. Again, we can shift it manually 1 to the left, 3 up. Okay. Or we can plug it into the, substitute it into the equation. So 0 minus 1 is negative 1. 3 plus 3 is 6. So that new point is going to be right here at negative 1, 6. Okay, then we have negative 4, 4. We can substitute that in. Negative 4 minus 1 is negative 5. 4 plus 3 is 7. Okay, or we can shift it manually. 1 to the left, up 3. Okay, and that should be negative 5, 7. Okay, and the last one's negative 1, negative 4. So we can plug it in. Negative 1 minus 1 is negative 2. Negative 4 plus 3 is negative 1. So negative 2, negative 1. Or again, we can shift it 1 to the left, up 3. Okay, then we can connect those points. It's going to kind of be over the top of the other one a little bit. That's okay. Okay, so there's our image now. So we took our original triangle, our pre-image. We translated it according to the mapping notation that was given to us. So we shifted the triangle, every point on the triangle, 1 unit to the left and 3 units up, and that's our new triangle, our image. Okay, we want to do the same thing for the next one. So let's pick a point on it. This is negative 1, 4. Okay, we can use the equation. So in this case, it's just x. So we're mapping x to x. So negative 1 is just going to stay negative 1. We're going from y to y plus 3. So that's 4 to 4 plus 3 is 7. Or we can think about it. We're going to shift it. We're not going to shift it horizontally at all because that's the same thing as like x plus 0. So there's no horizontal shift at all. So it's just staying at negative 1. And then we want to go up 3. 1, 2, 3. Let's pick the next one. Okay. Let's pick another point. How about this one? 1, 2, 3, negative 4, negative 1. Again, we just want to go up 3 points. That's it. So negative 4 stays the same, and this becomes a positive 2. And the last one is 3, negative 3. Okay, we want to substitute that in. 3 maps to 3, so it stays 3. Because x maps to x, so 3 maps to 3. Negative 3 maps to negative 3 plus 3. Negative 3 plus 3 is 0. Okay, or we can just count. We're not shifting horizontally, just shifting up vertically by 3. So our pre-image was what's already drawn. Now we translated everything up. We translated our vertices up 3 units. Now let's fill in the rest of the points by just connecting our dots, our vertices. So now we've drawn in the new figure, which is called the image. The other way we can go is we go in the reverse direction, where they give us the translation, and then we have to figure out what the notation is going to be. Okay, so for the next example, we want to find the rule that describes the given translation. So the rule that describes the given translation. Okay, so we want to go from point Z. Okay, point Z to point Y. Okay. So this is an XY plane, so we're going to start out with X comma Y. We're going to map, again, this X does not refer to this X, it refers to the X-axis. This Y does not refer to this Y, it refers to the Y-axis. So we have an X coordinate and a Y coordinate in our XY plane. These are just points in the plane. Okay, so we have X comma Y. We want to know how we get from Z to Y. So horizontally, we need to go 2 units to the left, and then we need to go 4 units down. Okay. So we need to shift point Z 2 units to the left, and then we need to shift it down 4 units to get to Y. So that's going to be X minus 2, because we're shifting left 2, comma Y minus 4, because we're shifting down 4 units. Okay. Left 2, down 4. Okay, if we want to write the points in, maybe that might be clear. This is negative 2, 2. And this one is negative 4, negative 2. So to get from negative 2 to negative 4, we have to go negative 2. To get from 2 down to negative 2, we need to go down 4. So we have negative 4. Next one's asking us to go from Y to W. Y to W. So here's Y. Here's W. So again, Y was negative 4, negative 2. W is 0, negative 4. So how do we get from negative 4 to 0? We have to go 4 units to the right. So that's X plus 4. We need to go 2 units down. We need to go down from negative 2 to negative 4. That means we need to go minus 2. And if we substitute in our original point, negative 4, negative 2, right, our equation should work. So negative 4 plus 4, negative 2 minus 2, negative 4 plus 4 is 0, negative 2 minus 2 is negative 4, which is what we got. Okay. So we know we did it right. Okay. Third one here is W to V. So to get from W to V, we need to go right 2 and up 2. So here's W and V. Again, this was 0, negative 4. I want to go to V. That's going to be 2, negative 2. How do we get from 0 to 2? We go right 2, so we go plus 2. So again, we need to put our X, Y. That's our original point in the XY plane, our X and Y coordinate for the preimage. We want to find out where that point gets mapped to. Where is it getting moved to? Okay, if we translate it, where is it going? How do we go? This was this point was the preimage, and this point was the image. How did we get there? We mapped it from X, Y. X had to move over, had to shift horizontally 2 to the right. Y had to shift vertically up 2. Again, if you put in your original point, 0, 4, you'd get 0 plus 2 is 2. Negative 4 plus 2 is negative 2. Okay. Z to U. So again, Z is negative 2, 2. And U is 3, 1. How do we get from negative 2 to 3? We have to go to the right 5. 1, 2, 3, 4, 5. And we have to go down 1 from 2 to 1. So that's going to be x, y. X is getting mapped to x plus 5 because we're shifting it. To get from z to u, we need to go 5 units to the right. Right? 1, 2, 3, 4, 5. Okay, I mean, that was not 5. And we need to go down 1. It'd be good if we had the whole grid mark on here, but that's all right. Down 1, so that's minus 1. Okay, and then the last one here, u to y. So here's u, here's y. Again, u is 3, 1. Y is negative 4, negative 2. So how do we get there? We have to go left 7. 3 to negative 4 is 7. So 1, 2, 3, 4, 5, 6, 7 to the left. So x minus 7. Then how do we get to negative 2 from 1? We have to go down 1, 2, 3. So that's y minus 3. Okay. What is an isometry? An isometry just means that the image and the preimage are congruent. Image, preimage, and the preimage are congruent. The image and the preimage are congruent. I'm just going to throw 1 through 6 on here real quick, I think. And I'll do 7 through 12 in a different video. Okay. Well, that's fine. We'll do 7 through 12 in a different video, I think. So we'll stop there for notes.